In this video, I'll show you how to solve the ALEKS problem called Standardizing a Base Solution by Titration. This problem is asking us to calculate the molarity of a sodium hydroxide solution. As you probably know, molarity is calculated by taking the moles of something and dividing it by the volume in units of liters. Now, specifically for this problem, we're talking about the moles of NaOH and the liters of this NaOH solution. And I do want to say, as a side note, I looked at quite a few versions of this problem, and every version that I looked at was using sodium hydroxide as the base. It is possible that maybe you have lithium hydroxide or potassium hydroxide. If you do, don't worry about it. That doesn't change the solution to this problem at all. Okay, so in order to calculate molarity, we need to know both the moles of NaOH and the volume of NaOH, and we're going to start with the volume. ALEKS actually tells us the volume of the NaOH in the problem itself. Now be a little bit careful because there are two volumes in the problem. ALEKS is going to give you two volumes. It's going to give you the volume of water that's used for the titration, and that is actually not useful information. Block it out. You're never going to use that. What we do want to use is the volume of sodium hydroxide. Hydroxide is cut off over on the next line. This is the volume that we are going to be plugging into our molarity equation down here. Now, of course, this volume is in milliliters, and so that means we are going to need to convert it into liters, but that's fine. That's easy. We can do that. So we know from the problem statement, we know the liters of NaOH. Our job is to figure out the moles. That's what we have to calculate. And we're going to do that by doing a titration calculation, and a titration calculation is just a special type of stoichiometry calculation. This particular titration is an acid-base titration. We have an acid that we are reacting with our base, and in order for us to do any type of stoichiometry, I mean, technically we need a full-on balanced chemical equation to do stoichiometry, but actually in an acid-base reaction, we really just need to know the stoichiometric coefficients of the acid and the base as they react together in the titration. Now the base, what I'm going to do is rewrite this. The base in our specific titration is NaOH. And the acid in my problem is oxalic acid right here. Now, here's something that's kind of funny. I looked at a lot of versions of this ALEKS problem, and every single version that I looked at was using oxalic acid. It was using it every single time. I don't know if that's just a coincidence for me. I don't necessarily trust that it's going to be oxalic acid every single time. Maybe it will. That would be cool. But regardless, whatever acid you have here, ALEKS is going to follow up and tell you something about that acid. It's going to describe it as a diprotic acid or a triprotic acid. That's going to give us information to determine the stoichiometric coefficients in this equation for this reaction that is occurring in the titration. Now, if we have a diprotic acid, which I do, I'm just going to write di, the diprotic, which is the prefix for 2, means that that acid reacts with 2 molecules of NaOH. If you have an ALEKS problem that says that it's a triprotic acid, tri being the prefix for 3, that means that the acid reacts with 3 molecules of NaOH. And if you have a monoprotic acid, or if ALEKS just doesn't describe it at all, doesn't say anything, if it doesn't describe it at all, then we're going to assume that that means that it's a monoprotic acid and it reacts with 1 equivalent of NaOH. So based on whatever word ALEKS is using to describe the acid, you are going to need to choose the appropriate equation for your particular titration in order to get the stoichiometric coefficients correct. Now what we're going to do is figure out how many moles of this acid we have, and we're going to use stoichiometry to convert those moles of acid into moles of NaOH. And once we know the moles of NaOH, we can just plug that into this molarity equation. Remember, we already know the liters, so this is just the last thing we need to figure out. ALEKS doesn't give us the moles of the acid directly, but it does give us the mass of the acid. So that just means we're going to take the grams of the acid provided to us in the problem. We're going to do a gram to mole conversion and then a mole to mole conversion, and then we'll be done. Now my problem is giving me units, starting me off with units of milligrams. So I am going to need to do an initial step of converting these milligrams of acid into grams, 52 milligrams of, I'm just going to write acid, even though I know it's oxalic acid. And my first step is going to be to convert out of milligrams and into grams Milli is the prefix for 10 to the minus 3, so that conversion is going to look like that. And that is going to get me into units of grams of acid. Now you're going to need to know the molecular weight of the acid. I went ahead and looked that up ahead of time, and the molecular weight for the oxalic acid is 90.03 grams per mole. I want the gram unit down on the bottom of this conversion factor so that it cancels out. And so I'm going to do 90.03 grams of the acid per mole. And that's going to cancel those units. And in those two steps, I've done this portion of the conversion, and now I'm ready to convert from moles of acid into moles of NaOH. I want moles of acid down on the bottom, and I want moles of NaOH up on top, and this is where we're going to go back to those equations to figure out what the conversion factor is for this particular last step. Now remember, you are choosing an equation based on if you have a diprotic acid, which I do, or if you have a triprotic, or if you have a monoprotic acid. For all of these reactions, for every single one of them, the stoichiometric coefficient on the acid is 1. And the stoichiometric coefficient on the base is either going to be 1, 2, or 3. Because I have a diprotic acid, my stoichiometric coefficient for NaOH is a 2. So that's going to cancel out my moles of acid, and when I do all the math on this, I'm going to be in units of moles of NaOH. So using my calculator, I've got 52 times 10 to the minus 3. I'm going to divide that by 90.03 and then multiply by 2, and that gives me 0.001155 moles of NaOH. Now remember, our job is to calculate the molarity, which is the moles per liter. So I'm going to just copy that again down here. We need our moles of NaOH divided by liters of NaOH. I just calculated my moles of NaOH, which is 0.001155. And I need to divide that by my volume, 32.4 milliliters, which is the same thing as 34.2 milliliters, which is the same thing as 0.0342 liters. 0.0342 liters, put the mole unit up on top, and that's giving me a molarity of 0.034 when I round to 2 sig figs.